We finished adding the buildings and the walls to our project area, and now we can look at the hydraulic structures. So there is hydraulic structure data in QGIS Lesson 6. QGIS Lesson 6 is kind of a two-part lesson. The first part is the basic lesson, how to set up the culverts if you only have rating table data. And then the advanced part of the lesson will be how to apply how to convert some of the culverts to use the generalized culvert equation. But we start by dragging and dropping the hydraulic structure shapefile onto the map. Let me minimize this and get these. And then of course it comes in with a very muted color, so we want to modify the color. But in this case it's a little different because we don't want to use the simple line. We want to use an arrow, and that way we know the flow direction of our culvert. But we can still change the fill to something, that is a little bit brighter. Let's see what that does. Okay, that looks okay. That looks okay to me. That just changes the fill of everything. Now if you zoom in onto your culverts, you'll see that you have, not only do you have a nice bright color, but you also have a flow direction. And that is because the arrow tool, or the arrow symbology, will apply an arrowhead to the last vertex in the polyline. So the first vertex represents the inlet, and the second vertex represents the outlet. And the culverts will pick up data from the inlet, move it to the outlet, or if you use a if you use a tailwater control, they may be able to reverse that flow. But the way that you want to set them up would be their typical flow direction. So these structures are designed to take water from the inlet and move it to the outlet. Let's talk a little bit about some of the elevation issues related to setting up hydraulic structures before we move on to actually processing the data. So hydraulic structures will pick up water from the inlet and move it to the outlet, but because they're typically assigned to a head wall or a culvert or something like that, there is always a problem with the fact that there is a transition in elevation on the culvert. So for example, if you look at the elevations of the 1409 and 1407 and 1409, and then if you look down here, we have 1408 and 1406 and 1405. So you can see that this is not the invert elevation of this layer. And so you need to modify the elevation of this grid element so that it represents the invert of the elevation that feeds through your culvert. Now I'm going to do the ID tool on this elevation layer. So if I click ID and I click right here, you see that it's 1410. But if I click right here, you see that it's 1405. But of course, if I move back to this tool and I highlight this grid element, you see that this grid element elevation is 1409. It's an average of all the pixels inside this element. But what we want is an invert elevation. And not only do we want an invert elevation right here, but we want an invert elevation all along this little channel so that the water can be picked up and carried down to the inlet of our hydraulic structure. So we will be doing an elevation modification to correct that. Let me show you one more of these so that you see how and why we set these up the way that we do. So same thing here, right? Our invert elevation is 1390 and on the upstream side, and our invert elevation on our downstream side is 1385. But we have in here a weir that probably is taking this basin right here, and it doesn't want to collect the sediment from this basin right here, so it has a weir that helps eliminate sediment and trash from this basin pouring into what we'll call here a stilling basin. So this stilling basin will collect the discharge from this side of the culvert and pass it through the culvert, but it doesn't want to get all the debris and trash from this larger basin upstream, so it has a weir applied right here. So, but if you look at your grid elevation and you click on these as a grid elevation, that says 1392, but the invert elevation is 1390. And if you look at, now I'm going to go back to the elevation, and if we look at the weir elevation, it says 1396.5, and and if you look across it, 1396.5, and then of course, whoops, am I getting that? I don't feel like that's changing. Okay, there we go. And then of course, as we kind of move up, you see that 1396.5 is going up to 1396 or 1397 up here at the top of our stilling basin. And then there is also a bit of a scupper right here that allows water that's coming down the street to pour into our basin. So there's a scupper that allows the street flow to pour into our basin. So we need some elevation corrections not only on the grid element invert here, but also possibly across the roadway here, so that we can allow water to flow down the roadway and through the scupper and into our stilling basin. So we need some elevation modifications for this structure. We can probably just move this point down one grid element so that it can share with the correct invert on the downstream side, and then do an elevation correction here on the upstream side. And then let's do an assessment of one more, because we have one more very large structure that will be taking, so the storm drain system goes underground and under this culvert here, and then the overland system will capture water at the upstream side of this culvert and pass it through to the downstream side of this culvert. And so again, as you can see, if I were to assess the elevation where it wants us to put the inlet point of this culvert, that elevation says 1428. But if we move one cell upstream, we get 1426. And if we use the elevation ID tool, you'll see that we get 1426 and 1425. So the invert elevation of our culvert is 1425. So we can do an elevation correction on this side, or we can do our elevation correction right here and put the grid elevation to 1425 and then move the inlet of our culvert to this grid element. And then on the bottom side, same thing. If I pick up the elevation of this, it's going to be higher than the elevation of this. So I can just move my culvert outlet point down one grid element to get it away from that place that has the head wall interference. And these are just considerations for every culvert that you have to make. Now let's look at one more spot where our culverts will be sharing with our channel. So in this case, we have water that is coming down the street and coming through a scupper right here into the street flow, and then flowing south into this culvert inlet. So again, here we will need an elevation correction along this small trapezoidal channel so that the water can travel to this inlet. And then this is might look kind of weird, because this outlet on this side may actually be assigned to the very bottom of the channel, or it may be a bubble up, or it may be assigned to the right bank of the channel. But because of the way that Flow 2D works, we need to assign it to a left bank, because when we exchange discharge from this side of the structure to this side of the structure, we are exchanging discharge to the cross section, not the grid element. So we assign it to the left bank because the left bank is how we identify which cross section that we're sharing with, because the right bank can be in the right bank there can actually be two grid elements assigned to a right bank. So when we make our cross section and our hydraulic structure and outfall assignments, they always need to be directed to the left bank because they are sharing to the cross section, not the bank. Okay. So that's basically it for a review of these cross-section data. Oh, there's also one more thing we need to do with our hydraulic structure, and that is to give it a label. And we need our labels to be assigned to the structure name. And there are many fields in here, but usually when you have the word name in one of the fields, it picks it up as the value to be reported to your labels. So structure name, and if I click apply, you may not be able to see that until you zoom in. And it's not the cleanest of data, so maybe one of the things we can do is change the color of the label to something a little more visible. Let's try that and maybe make it 12 points instead of 10 points, and click apply, and now you can see that it shows up a little better. But no, it will only show up when you're zoomed into that culvert, and we'll need to identify that later. And one more thing about these structures is that they also have one more important feature. So if you open the attribute table, you see here that they have the structure name, and this is important. The name of this structure is assigned correctly. They also tell you whether or not they are a floodplain to floodplain structure, floodplain to, sorry, let me get off that tooltip, floodplain to channel structure, or a channel to channel structure. So I'll show you that here. A floodplain to floodplain structure would be one of these, where you can see that it's going from a floodplain grid element to, a floodplain grid element to a floodplain grid element. And a floodplain to channel structure would be one of these, where you can see that it's going from a floodplain grid element to a channel. And in this case, it would be a channel left bank or a channel cross section. And then the final, or another one, would be a channel to channel, but of course we did those back in the channel lesson. So these ones would be a channel to channel. This one would be a floodplain to channel. And you need to be careful to make sure and assign it to a left bank. And these ones here would be floodplain to floodplain. Let's see what else is in that table that might be important. Right click, open attributes. Okay, in the first part of the lesson we set all of them up using a rating table, but in the advanced part of the lesson we'll be changing them to a culvert. This determines their tailwater switch. I typically start with that set to 0 and let the model tell me when it wants to set it to something else. A head reference elevation, we'll discuss that when our culverts are in, and we'll discuss these parameters before we export the data. So I'm going to pause or stop the video here, and the next video will be how to set the culverts up in your data files or in your data layers.